Elon Musk has been ramping up plans to produce the Tesla bot, with ambitious goals for this year and next. More than the electric vehicles themselves, the Optimus humanoid robot has the potential to generate billions of dollars and transform Tesla into a company valued at a staggering $25 trillion. The revenue would come not only from the direct sale of these robots to customers, but also from their implementation in Tesla's own factories. Replacing human workers with robots could save tens of thousands of dollars per employee annually. That's why Musk believes Optimus will be the most valuable product in the company's history, to the point of calling it his biggest project yet. The entire Tesla bot production line will be based at Giga Texas. But how is Optimus being manufactured? Will its price really be $20,000? To ensure the project moves forward on schedule, Musk has set bold goals for 2025, focused on integrating the humanoid robot into the company's operations. The plan is for Optimus to take on basic tasks within the factories, even participating in the assembly process of electric vehicles. Musk also revealed that his goal is to have at least 1,000 Optimus units operating within Tesla by 2025, with the possibility of that number rising to 10,000 quickly. This means that Tesla could start selling some units as early as the end of this year, with a more significant expansion in 2026. Recently, Musk made a shocking announcement. Large-scale production of the Tesla bot would begin in 2024, with the goal of manufacturing between 500,000 and 1 million units by 2027. The projection includes the delivery of 5,000 robots by 2025, with the last quarter of the year marking the start of construction of a new factory. By 2026, production would increase to between 50,000 and 100,000 units, and reach 500,000 to 1 million robots by 2027. These numbers are impressive. To put it in perspective, producing 5,000 robots per shift is equivalent to the number of human employees on a single shift at a Tesla factory. No other robotics company has come close to promising production scale at this level, not even Boston Dynamics. Optimus is currently being produced at Giga Texas, one of the most advanced technology complexes in the world. Although it does not yet have a fully dedicated assembly line, Tesla engineers have already hand-assembled more than 100 units, demonstrating an innovative and flexible approach in this early phase. At a recent event, about 50 of these robots were unveiled to the public, interacting directly with attendees and becoming the main attraction. To date, Tesla remains the only company in the world that allows customers to experience a humanoid robot in such an accessible way. Has any other company managed to do this? Musk has even stated that Tesla could manufacture billions of Optimus units in the future. This may seem far-fetched at first glance, but considering the company's capabilities, it is not impossible. He compares this vision to the automotive industry. Today, around 100 million cars are manufactured per year, which meets global demand, considering there are approximately 2 billion vehicles on the road. The difference is that, while cars are mainly used for transportation, humanoid robots can generate income by performing a wide range of tasks. They can work in restaurants, serving drinks, cooking, or cleaning, creating new sources of revenue. Given this potential, Musk predicts that annual production of robots could eventually surpass 1 billion units, making Optimus as common as smartphones. However, he also acknowledges that manufacturing thousands, then hundreds of thousands, and eventually millions of these robots will be a huge challenge. For Optimus to reach this scale of production, it will need to collect massive amounts of data and train its systems intensively. Currently, some criticism has focused on the way the robot walks, with humorous comparisons to a drunk person or an 82-year-old man. In a recent video, it was seen climbing and descending uneven terrain, and although its movements are becoming more natural, there are still noticeable difficulties, especially on slippery surfaces. Although Optimus has already demonstrated its ability to climb stairs, descending them is still a more complex challenge, requiring advanced techniques to maintain balance and avoid falls. However, Elon Musk assures that the robot will soon be able to move across different types of terrain and handle a wide variety of objects. An impressive detail was revealed in the video in which Optimus walks on uneven surfaces, The robot was completely blind, that is, without using its cameras to see the environment. Instead, its movement was guided exclusively by internal sensors and the onboard intelligence system. These sensors analyze the texture of the ground, process the information in real time, and adjust its movements as necessary. Currently, Optimus moves mainly on flat surfaces, such as factory floors, where it maps the environment and avoids obstacles using 3D cameras to obtain a detailed view of the space around it. However, Tesla has already tested the robot on unfamiliar terrain and without visual aid, demonstrating its ability to adapt. Many have noticed that its walking posture resembles that of some public figures, which has generated humorous comparisons on social media. Elon Musk has commented that seemingly simple tasks, such as pouring water into a glass, are actually extremely challenging for a robot. Small errors in understanding how to hold a container can result in unexpected failures. The development of Optimus Hand alone required almost half of the entire technical effort of the project. This is because a large part of human intelligence is linked to the manipulation of objects, something essential for interacting with the world around us. For the first time in history, a robotic hand has achieved 22 degrees of freedom, a remarkable engineering achievement. If Optimus' brain were as advanced as a human's, combined with this sophisticated hand, it could perform about 80% of the tasks that a person can perform. Musk has even stated that, with this level of precision, the robot could thread a needle, play the piano, and perform activities that previously seemed impossible for machines. In order for this hand to function naturally and fluidly, it was necessary to design a highly complex actuation system. The biggest challenge, however, was balancing the sophistication of this mechanism without compromising the shape and flexibility of the hand. If too many actuators are added, the design becomes bulky and loses the agility needed to perform delicate tasks. Furthermore, a curious detail that often goes unnoticed is that human fingers have different lengths, and this is no coincidence. If all fingers were the same size, the precision of movements would be drastically reduced. This difference in length allows us to perform delicate and complex tasks more efficiently. The little finger, for example, despite being the smallest, plays an essential role in the precision of movements. Losing this finger would considerably affect the dexterity of the hand. For this reason, Tesla designed Optimus Hand with 5 fingers of different sizes, mimicking human anatomy. This design allows the robot to perform tasks that require an extreme level of precision, such as holding an egg without breaking it, balancing a tray full of batteries, or serving drinks without spilling them. Creating a humanoid robot capable of performing most of the functions of a human being is an ambitious goal that few companies dare to pursue. However, the evolution of Optimus' arm, which went from 11 to 22 degrees of freedom, with actuators meticulously arranged in the forearm, represents an extraordinary technological advance, recognized by leading engineers. Each component of the robot, from the sensors to the actuators, was designed based on fundamental physical principles, replicating as closely as possible the biological structure of a human hand. Musk also explained that, as in a human body, most of the muscles responsible for the movement of Optimus' fingers are located in the forearm, ensuring greater precision and strength without compromising the mobility of the hand. Just like the human hand, which uses tendons to move the fingers, Tesla redesigned Optimus to adopt a similar actuation system, ensuring precise and natural movements. To achieve this, engineers position the actuators on the robot's forearm, while thin cables pass through narrow tubes to control the fingers. These cables act as artificial tendons, allowing for near-perfect precision in the hand's movements. In a video released last November, in which Optimus catches a tennis ball, the advances in this new design were clearly visible. On the left side, there was the latest version of the hand, now with 22 degrees of freedom, while on the right side, the old version still had visible cables and actuators, with only 11 degrees of freedom. The difference between the two generations was notable. The new version had a cleaner, more refined design, with all the internal components discreetly hidden. Even the finger joints seemed more integrated, giving the impression that they were protected by a kind of glove. This raises the possibility that Optimus could, in the future, perform tasks that involve contact with liquids, such as washing dishes or handling wet clothes, something that many potential customers questioned. From a technical and functional point of view, Elon Musk has already stated that Optimus' new hand is capable of performing extremely complex tasks, such as threading a needle or playing the piano. It seems incredible, but when you look at the demonstration video, you can understand why he is so confident. The robot picked up a tennis ball with impressive precision and held it firmly. It is worth remembering that, although Optimus was being teleoperated, this does not diminish the complexity of the feat. Typically, remotely operated robots face delays in responding to commands. But in this case, the reaction time was surprisingly fast, with practically no noticeable latency. According to Milan Kovac, who commented on the project on X, formerly Twitter, the Tesla team concentrated all the actuators in the robot's forearm, exactly as human tendons work. This approach not only made Optimus' hand lighter and more agile, but also significantly improved its accuracy when grasping objects. In addition, the team is still working on implementing more advanced tactile sensors that will cover a larger area of the robot's hands, allowing for a more sensitive response to touch. As Tesla moves forward with Optimus production, the company is refining every step of the process, from assembling the structure and integrating electronic components to fine-tuning the software. And one detail that will certainly catch the attention of future buyers: it will not be necessary to manually teach the robot to perform each new task. Instead, it will be enough to demonstrate the action through a video, and the artificial intelligence will automatically learn to reproduce it. This technology will drastically reduce training time and allow Optimus to be used in a variety of environments, such as schools, hospitals, and companies. However, to achieve this complete automation, Tesla is still improving the robot's AI and mobility systems, ensuring that it will be able to operate fully autonomously in any scenario. Many people are concerned about safety issues, but Elon Musk has already assured that Optimus will have nothing to do with the hostile robots from the Terminator or iRobot. On the contrary, its proposal is to be a friendly assistant for domestic and industrial tasks. Now, imagine a future where Tesla robots are responsible for manufacturing other robots. This is no longer just a distant concept, but a goal that the company is getting closer to achieving. With the goal of producing 1 million Optimus units, Tesla is betting heavily on vertical integration, a strategy that reduces costs, speeds up manufacturing, and ensures high-quality standards. To achieve this, the company relies on cutting-edge technologies, such as industrial 3D printers, quality control systems based on artificial intelligence, and a large-scale production capacity for essential components, such as batteries and chips. All of this puts Tesla in a privileged position to enable mass production of Optimus. The company aims to manufacture 10,000 units of the robot by 2025, which does not represent a great challenge for a company that operates the gigantic Giga Texas, a 930,000 square meter factory capable of producing hundreds of thousands of Model Y vehicles annually. To start the Optimus assembly line, Tesla would only need to optimize a small space in the factory and make minimal adjustments to existing equipment, which is currently used to manufacture electric cars and batteries. It is worth remembering that Optimus uses the same 4,680 batteries as Tesla vehicles, and the company's expertise in manufacturing this type of component represents a huge advantage in terms of both cost and performance. Thus, not only is the short-term goal of 10,000 units feasible, but the scalability of the project allows production to quickly grow to millions of units in the coming years. From the beginning, Musk has emphasized that Optimus will be especially useful for the elderly and children, thanks to its ability to continuously learn and adapt to different situations. Its advanced artificial intelligence system allows it to answer questions in real time, making it ideal for helping the elderly use smart devices or even serving as a tutor for children's learning. With its precision and balance, Optimus could also be tested in hospitals from 2025. In these environments, it could assist patients with mobility difficulties, remind them about medication schedules, and even monitor vital signs, such as heart rate and blood pressure. In addition, Optimus has already demonstrated its versatility by acting as a bartender and even as a performer at Tesla events. In the future, its integration with the entertainment and hospitality sector could expand even further, allowing robots to be used to welcome guests in hotels, provide room service, or even serve as guides in resorts and theme parks. Its interactive and user-friendly design makes it a natural choice for roles that require direct interaction with the public. In industry and logistics, Optimus will continue to play a key role, but future updates could expand its capabilities to handle more demanding tasks. It can currently lift loads of up to 11 kilograms and move across different types of terrain, making it suitable for construction, component assembly, and warehouse management. Its ability to climb stairs and travel on inclined surfaces ensures flexibility for use in multi-story industrial environments. Elon Musk has already mentioned that Tesla is working to make Optimus even lighter, without compromising its strength, which will help reduce energy consumption during use. This evolution is in line with advances in the company's manufacturing processes, which focus on making production more scalable, affordable, and efficient, bringing Optimus closer to the reality of homes and businesses around the world. In fact, Musk recently shared on his X social media account that Optimus is already performing some tasks within Tesla's factories and that its capabilities are evolving rapidly. The biggest challenge, according to him, is to adjust the robot's design to simplify its production and structure a supply chain that is efficient enough to enable its large-scale manufacturing. The third generation of Optimus is expected to be revealed later this year, possibly in the first quarter. Although some technical challenges are delaying this new version, this only reinforces Tesla's commitment to creating a revolutionary robot. In the early stages, the need to operate Optimus remotely is essential to overcome technical limitations. However, it is important to look beyond these temporary difficulties and see Tesla's long-term vision. In just over 2 years, the company has already presented 3 generations of the robot, demonstrating an impressive technological advance. Musk does not see Optimus as just a functional robot, but as a fundamental piece to transform the way we interact with technology in our daily lives. When it was announced in 2021, many doubted its potential, especially due to its initial limitations. However, if we compare the first version of the Tesla bot with the most recent model, it is undeniable that the evolution has been gigantic. Optimus is not just a robot, but a milestone in the history of robotics and advanced manufacturing. Do you believe it can transform the way we live and work? With the advances that Tesla is bringing, this reality seems to be getting closer and closer. If you like this content and want to continue following Tesla's innovations, don't forget to like the video and share it with your friends. Subscribe to the channel and turn on notifications so you don't miss our next updates. Thanks for watching and see you in the next video.